Hey CTM students and anybody else who might be watching, welcome to Chapter 6 in our book for contemporary topics in mathematics. Here we are going to be starting a chapter on algebra. So it's some algebra review. If you're in CTM, you've seen this stuff before. It's a review at least for you. If you're not in contemporary topics in mathematics, perhaps you're just a brand new algebra student, you'll find this stuff hopefully very helpful as you start to or begin to learn about algebra. So either way, make sure you're using those extra examples in your book. If you're one of my students, either way, hopefully you find this helpful either as a review or for the first time, seeing it for the first time. So order of operations, why does it matter how you do things? Why does it matter what order you do things? Well, pretty much so this doesn't happen, mathematically speaking, so you don't put your socks on over your shoes. I don't know if this is supposed to be some sort of fashion trend. I'm not seeing it. I'm sorry. You're just going to get holes in your socks, and no, it's not going to work for me. Or pantyhose. This looks like pantyhose. That looks ridiculous. Anyways, so order of operations, this is what it is. Or this is the order in which we do things, mathematically speaking. So step one is a P. We'll talk about what P stands for in a second. You've heard, I would imagine, the phrase PEMDAS before, if you've ever learned order of operations before. Let's write that down right here. PEMDAS. Some people affectionately refer to this as "please excuse my dear Aunt Sally." Oh, she's just a handful right there, that dear Aunt Sally. But that's another way to remember this. Please excuse my dear Aunt Sally. P stands for parentheses, E for exponents. So let's fill this out as we go here. Parentheses. And E for exponents. M stands for multiplication and D for division. This is something you should listen closely to here, because a lot of people have this misconception that division always would come after multiplication, which is not true. These two are kind of grouped together. Division is just a different way to think of multiplication. It's just like the reciprocal of what you're multiplying by, in a sense. So if you divide by 3, it's the same as multiplying by 1/3. If you divide by 5, it's the same as multiplying by 1/5. If you divide something by 5/2, it's the same as multiplying by the reciprocal of that, 2/5. And so division and multiplication are essentially the same thing. That's why they are of the same importance. So I want you to write that down next to this, multiplication, division. Don't make this common error. I've seen this a lot on social media sites and whatnot. Somebody will post a question and it will be an order of operations question, and all kinds of people will get it wrong because they assume division comes after multiplication, when in fact it doesn't. They're the same importance. So you just move left to right. When you see multiplication and division, just go left to right. So if multiplication came before division, left to right, yeah, you'd do it first. But if division came before multiplication, you'd do division before multiplication. And the same sort of thing applies to addition and subtraction here. That's what these last two are, addition and subtraction. If you're adding something, that's the same as, in subtraction terminology, if you're subtracting something, I should say that instead, that's the same as adding a negative number. So we can think of addition and subtraction essentially being the same things as well. And that puts them on the same level of importance. And again, we just go left to right. If you're one of my students and I see you wearing something like this someday, I'm just going to shake my head and I will just say, you know what, I think you did your order of operations wrong this morning. Okay, so again, here's another good example of why order of operations is so important. People putting in groceries into grocery bags, you don't want to put the eggs on the bottom and then put the watermelon on top of the eggs. Yeah, what's the difference? I don't know. I'm stuffing my face full of cookies while you're taking care of this nasty eggs that got all crushed under the watermelon because you didn't follow order of operations, okay? Order of operations is important in many things in life, it's important in math as well. So I want you to evaluate the expression below for x equals 5. And before I move on, seeing that word evaluate just made me think of coming back to this, to the vocabulary again. If you're one of my students and any of these terms or phrases doesn't ring a bell to you, you should definitely read your book. This is coming on pages, these definitions, coming on pages 288 and 289. So go back and review those pages as necessary. If you are new to algebra, you definitely would want to make sure you understand what these words mean before moving on to the examples like this. So here's example 1. We've got this as my expression. I'll try to say as many of these vocabulary terms within the context of what I'm doing here, or define them within the context of what I'm doing, but I'm not going to write out formal definitions of these things. So here's the expression. This is an expression and not an equation, because there is no equal sign here setting two expressions equal to each other. So an equation is different than an expression because there's no equal sign. So here's an expression. It's kind of a long one because I want to practice order of operations here and make sure we have that down. So here's your original expression. We're going to plug in x equals 5 wherever we see an x. That's what evaluating the expression means. So we're going to evaluate this when x equals 5. And you notice here I've drawn brackets instead of parentheses, but they're just another way to write parentheses. The reason I didn't write another parentheses here, just because it makes it stand out a little nicer. It makes it easy to tell that this is closed right here and then this one's closed right here. So let's plug in the number though, 5. We're plugging in x, replacing it with a 5. And that's still 3. This is squared plus 3 divided by 7 times 8 plus 4 cubed minus, and now 2 times, I'm going to plug this in with a parentheses because I want to make sure I multiply these two numbers together. Okay, so now we follow our order of operations. So are there any parentheses first? Yes, there are. So we should try to simplify within the innermost parentheses first. So I should simplify here. I've got two sets of parentheses, this outside one and this inside one. I want to simplify this before simplifying this one. And so here, that would give me, this would be a 2. So I'd have 2 squared plus 3. This is still here. I didn't use the divide by 7 or multiply by 8 part. And then over here, I would want to take the exponent first. Now, Pemdas Exponents comes before multiplication and division. So I'm going to do this next. 4 cubed is 4 times 4 times 4. 4 times 4 is 16, and then 16 times one more 4 would be 64. And so here, I'm going to leave this like this for now, just so we get that practice. I know the next step it's going to change to, when we evaluate it, or when we simplify it, it'll change to 10, but let's write that in the next step for now. Okay, so this is exponents before addition for sure. I want to do that first. This would be 4 plus 3, and again, still divided by 7, still times 8. This will be 64 now minus 10. And then simplifying this, I'm keeping my brackets just to show you that this whole thing simplified down to this one number here. And this is divided by 7 times 8 still. And then this whole set of parentheses simplified down to this, to 54. From there, now I see division, I see multiplication, and I see addition. I did this on purpose. A lot of students that I've had in the past, shame on them, boy oh boy, they didn't understand order of operations correctly. They would do this multiplication before the division, but because multiplication and division are of that same importance, if you see multiplication and division, you just need to move left to right. We're going to do multiplication and division before addition though, so I do want to move with this stuff, just move left to right. 7 divided by 7 would be 1. So I have 1 times 8 plus 54. And now multiplication comes before addition, so this would be 8 plus 54. So 1 times 8 is 8, and 8 plus 54 is 62. So that's it. That's the final answer for something like that. Let's check out a second example. So example 2. This one I'm going to throw two variables into the equation. A variable is just a letter or a symbol representing a number in an expression or an equation. So evaluate the expression below for x equals 2 and y equals 6 now. So let's say this was your expression, negative 5x squared plus 2xy minus 3y cubed. Let's say that was the expression. What are we going to do? We're going to say that x equals 2 and y equals 6. We're going to evaluate it by plugging it in. So I have this is going to equal negative 5 times positive 2, there we go, times positive 2 squared plus 2 times 2 times 6. The 2 and the 6 came just from here and here. And finally, minus 3 times 6 cubed. So again, we want to do exponents before we would multiply, and we'd want to multiply before we would add or subtract. So keep your order of operations going correctly. Exponents first here, that would be a 4. 2 squared, 2 times 2. This I'm going to leave like that because there's no exponents here. I'm going to leave it like that for now. This would be 6 cubed. 6 times 6 is 36. And then times one more 6 would be 216. From there, I'm going to multiply now. So negative 5 times positive 4 is a negative 20, and negative times a positive is a negative. Here 2 times 2 times 6, that would be 4. 4 times 6 would be 24. And finally here, 3 times 216, it's a negative though, negative times a positive, so it's going to be negative. 3 times 200 is 600, 3 times 16 is 48. Put those together, you've got negative 648. So now it's just addition and subtraction. Now, again, those are of the same importance. Addition and subtraction, that's your step 4. We just move left to right now. So negative 20 plus 24, that would be a positive 4. And I have minus 648. And then from there, 4 minus 648. You have the positive number here. The negative number is much larger. Your answer better be negative because of that. And you would just be taking 4 more than this, basically. This is another way of saying negative 648 plus 4. That's another way to think about that. That would be negative 644. And let's check out a third example now. So let's determine whether 2 is a solution. And I say is a solution because sometimes there's more than one number that actually works in an equation, but we're going to see if 2 is one of these solutions, or maybe it is the only solution, we don't know, but determine if it is a solution to the equation 4x squared minus 3x plus 13 equals 23. So to determine if it is a solution, that's essentially saying, does 2, plugging into evaluating this side, or this whole equation, with a value of 2, does that make this a true equation? Does that make it actually work? Does it balance it out? So think of, you don't have to draw this, but think of algebraic equations as being like a scale maybe that you've seen in a science class, something like that, where they'll put some weights, or they'll put this unknown object on this side, maybe it's a rock or something, and then you put these gram weights or kilogram weights over here and you try to balance it out. That's like saying this equals this, whatever's on this side equals this side. This is something you don't know, maybe that's your x, but then this you're saying is like, oh, 50 grams plus another 10 gram weight plus a 1 gram weight, something like that, and then you can figure out what x is. That's the same sort of concept as we have with algebra, and that's what we're doing. We're saying that this side equals this side balances out with this side. So let's check it out. Let's see if it actually balances out. So we have 4 here, and then we're going to have 2 squared. plugging in a 2 wherever we see an x. I'm using parentheses to do that, so I know to multiply these things in my next step, or in my later steps. Now, we don't actually know if this is equal yet, so there's something else I want to do, something in addition to this that I want to do. I don't know if it's equal, so I want to put this above the equal sign here. So let's put a question mark above there. Use your different color for this little part right here and say that we're using this because we're not sure yet if these are actually equal. So we're not sure yet if equal. That's where the equals sign with a question mark comes in. So now I see exponents. Exponents is going to come before multiplication and definitely come before addition and subtraction. Let's do that part next. So we're going to have 4. And later on you'll start to notice, if you haven't noticed already, that yeah, you could multiply this in the next step or within the context of this step and still get the right thing. As long as you did your exponents here first before multiplying this by this, then you're going to be good to go. But I'm just waiting until the next step, so I do all my multiplication at once. Here I did all my exponents at once. Now let's do all the multiplication. This would be 16 and this would be 6. And so still not quite sure yet. I'm going to put a question mark above the equal sign, but if I add and subtract this stuff together, now subtraction here coming first before addition, but remember these are the same importance, so just move left or right. This would be 10 plus 13. I'll keep the equal sign. I think at this point it's pretty clear though, but until the very last step show me yes, 23 does in fact equal 23. So I would put a little check mark, something by that. That did check out. The solution worked. 2 was a solution, or what we thought might be a solution worked. So when we plugged it in, it worked out. Therefore, since 2 makes the equation a true statement, we can say that 2 is a solution. So that's my answer to the question originally posed. It is a solution. Yes, it is. So 2 is a solution to the equation. And so that's going to do it for us for this lesson. Just seeing those 3 examples. If you're in CTM, my class, you probably found that hopefully a good and helpful review, but you probably found that not too hard. I'm hoping, I'm crossing my fingers on that one, that was more or less some basic algebra review for you. If you're new to algebra though, hopefully you found that not too hard as well, and hopefully that'll help you on whatever you're working on. Okay, so have a good rest of your day, and I will see you guys later.